Hello, this is Victor. Welcome back to the Victor's Learning Hub channel. And today we're going to be going through average rates of change. So what I'm referring to here is from the Year 11 Jacaranda textbook. And this is going to be covering Year 11 of Unit 2 of Methods. And it's going to be topic 3 on the Introduction to Differential Calculus. And our syllabus link today is going to be to determine the average rate of change in a variety of practical contexts. So our key cognitive verbs here are determine, the average rate of change in a variety of practical contexts. So a practical context, all it's actually saying, it's actually really just referring to real life scenarios and how we're going to use mathematics to solve these real life scenarios. So, and this is something you're going to be doing a lot more through senior, especially for your complex familiars and unfamiliars. Okay, so all we're going to be really referring to throughout the video is this formula right here, the average rate of change. So for the function of f of x, the average rate of change is our rise over run. You will obviously know this in year 8 for your gradient. And that's basically what the average rate of change is. And all they've done here is that they've just put this bit here right here in function notation really, just because we're getting to senior now and expecting us to know more of this high level knowledge, we're going to be using this equation throughout the video. Okay, let's get straight into it. The temperature of an iron rod placed in a furnace is described by the function T of small t equals small t squared plus 20 between t equals 0 and t equals 10. Okay, let's highlight the key bits of information we need to know throughout the question. So temperature and the function of t equals t squared plus 20 between t equals 0 and t equals 10. T represents the temperature of the rod in degrees Celsius, and the small t is the time in seconds. Okay, so we know our unit is degrees Celsius for temperature, and our unit for time is going to be seconds. Okay, part A is asking us to calculate the initial temperature of the iron rod. So the key word to be looking out for here is actually initial. And when a question states initial, it will usually referring to the x value equaling 0. So here, T is going to be equal 0 for the initial temperature. So we'll just sub that into our formula right here. So that's going to be T of 0 equals 0 squared plus 20, and that's going to be 20. So therefore, T of 0 is 20, and making sure we put our units degrees Celsius. Done, easy. Okay, part B is we're going to be sketching the graph of the function over the given time interval. So what is our given time interval? So actually, our given time interval is right here of t equals 0 and t equals 10. So all it's trying to say here is that t has to be greater than or equal to 0 and less than or equal to 10 seconds. So we want to be sketching the graph over this time interval. So obviously with t squared plus 20 here, we know this is a quadratic, so it's gonna look something like this. So all we need to be finding is our turning point and our y-intercept. So let's find our x value for the y-intercept, which we can do with x equals negative b on 2a. B is 0, a is 1, so this is going to be negative 0 over 2 over 1. So we know that x is going to be equal to 0. So we can actually see here that we've done this already in actually part A, where we've done this when the time has been 0. So we actually know that our turning point already is going to be 0, 20. Okay, great. And also, this actually represents our y-intercept conveniently at the same time because x equals 0 in this scenario. So we've actually already done the turning point of y-intercept. Okay, so now we want to sketch the graph over the given time interval. So now we need to sketch the graph over the given time interval. So we know that t is going to be greater than or equal to 0 and less than or equal to 10. So let's label 0 here and let's label 10 there. And that's just name our axes now. So we know that t is going to be time. We know that's going to be in seconds. And we know that the y value is going to be capital T for temperature. And we know our unit for temperature is going to be degrees Celsius. Okay, great. Awesome. So we know that the turning point is going to be at 0, 20. So let's indicate that. So let's put 20 here. Let's put a nice point for there. So we know this is 0, 20. And now we've got to sketch the graph of the function over the given time interval. So just it says just a sketch, so it doesn't need to be perfect. So a general drawing should be okay. So something like that really should be fine. Okay, great. So we've done that. So now it's asking us to construct a chord between the points where t equals 2 and t equals 8. So this is what we need to do. So we know that t equals 2 and t equals 8. All it's trying to ask us here is to actually try to find the y values, in this case temperature, at 2 seconds and 8 seconds. So all we're going to do is actually sub it into our equation. So we know that t of t equals t squared plus 20. So we can just state our equation again of t equals t squared plus 20. So let's calculate t of 2 first, which is going to be 2 squared plus 20, which is going to be 4 plus 20, which is therefore going to be 24 degrees Celsius. So now let's calculate t of 8 right now. So that's going to be t of 8 equals 8 squared plus 20, so that's going to be 64 plus 20, so that's going to be therefore 84 degrees Celsius. Okay, great, awesome. So now we know our y value, so all we're going to do is actually be plotting these points here. So we know that at t equals 2, it's going to be 24 degrees Celsius. So we know that at 8 seconds, it's going to be 84 degrees Celsius with this function. So let's label those points now actually on the graph. So let's start with 2 first. So we know that 5 is going to be in the middle. So 2 is going to be around there. 8 is going to be around here. Let's just draw a line to represent those points. So we know here T is going to be 2 and the temperature is going to be 24 degrees Celsius. So we can draw a little line right here. And we know this is 24 right here. And now we've got T equals 8 over right here. And we know that this point is going to be 84 degrees Celsius, so we can just say 8 and 84 right here, and then we can draw our little line intersecting the point, horizontal line, and this is going to be 84. Okay, awesome, great. So now let's go back to actually what the original question is asking. So we've basically plotted these 2 points right here, but we are still required to construct a chord. So a chord is basically where a line is going to connect to these 2 points. So what you want to do is grab a ruler. I'm going to be using my digital ruler here on OneNote, but making sure that when you're doing this in an exam and practicing your book, you use an actual ruler to make sure you get this accurate. So I'm going to angle my ruler here at 41 degrees and making sure that these connect the 2 points. And I'm going to draw a very clear chord here, making sure that it's nice and clear. So as you can see here, we have our chord right here, which is great. And for good reference as well, if required, you should also label the equation of your function as well. So we know that t of t is t squared plus 20, where t is less than or equal to 8 and greater than or equal to 0. Okay, great, awesome. So now D, determine the gradient of this chord. Okay, so that is pretty self-explanatory. All we're going to be doing is referring back to this formula right here of f of b minus f of a over b minus a for the average rate of change. So simply, it's our gradient. So we'll just use m for the gradient, and we are going to refer back to our 2 points here at t equals 2 and t equals 8. So we've got 884, and then we've got 224. So we've just got to sub these values in. So we've just got to synthesize this equation into the context of the question. So we know that it's going to be t of 8, because at 8 seconds, minus t, the temperature at 2 seconds. So that's the way you can interpret what is being said right here. The temperature at 8 seconds minus the temperature at 2 seconds over 8 seconds minus 2 seconds. So now we can substitute the values we've got here of t equals 24 and t equals 84. So that's going to be 84 minus 24 over 6. 84 minus 24, 60 over 6. Therefore, our gradient is 10. So that is going to be our final answer for the gradient. So part D is done. Okay, part A. Determine the average rate of change of the temperature between t equals 2 and t equals 8. So really, we've actually done that here already. So all this bit of the question, all it's asking is to actually determine the temperature, the average rate. So all we need to do is actually model this in a real life scenario, as I stated before. So we know that our y is going to be our t of the degree Celsius, and our x is going to be our time in terms of seconds. So making sure we actually use the units degrees Celsius and seconds here. So we know our gradient is 10, which is basically the temperature over the per time. So we can say, therefore, the average rate of change between 2 to 8 seconds is 10, making sure we put our units degrees Celsius per second. So yeah, that is all it is. It's just making sure we frame it in the practical situation we've been given, and as stated in the syllabus link here, we need to be using these in practical contexts. So that's what E is basically telling you to do, because the gradient of m equals 10, this doesn't really tell us anything, but saying the average rate of change between 2 to 8 seconds is 10 degrees Celsius per second, that's telling us something. All right, thanks for watching.